How organisms interact with their environment. Ecology. Ecology is the study of how living things relate to each other and their surroundings. Imagine trying to find the perfect spot in a crowded coffee shop to get some work done. Just like you assess the availability of outlets, noise levels, and comfortable seating, organisms interact with their environment by evaluating resources, threats, and suitable conditions for survival. In both scenarios, success depends on how well one can adapt and utilize the available resources. In the coffee shop, it's about finding the best spot to work efficiently, while in ecology, it's about organisms thriving by interacting with their surroundings to meet their needs. The part of Earth with life, its land, water, and atmosphere. Biosphere. The biosphere is the zone of Earth where all living organisms exist, interacting with land, water, and air. Imagine trying to keep your entire house clean and organized. It can be quite a challenge to maintain harmony between all the rooms and their different functions. Similarly, the biosphere is like Earth's house, where the land, water, and atmosphere are the different rooms that need to work together to support life. Just as a tidy living room, functional kitchen, and clean bathroom contribute to a well managed home, the cooperation between the land, oceans, and air creates a balanced environment where life can thrive, making the biosphere a well organized planetary home. A non living part of the environment, like water, light, or temperature. Abiotic factor. Abiotic factors are the non living elements of an ecosystem that affect living organisms. Have you ever tried to bake a cake, but realized halfway through that you're missing a key ingredient like eggs or flour? Just like the success of a cake depends on having all the right ingredients, the survival and prosperity of an ecosystem depend on abiotic factors such as water, light, and temperature. Without these non living components, similar to missing ingredients in a recipe, an ecosystem cannot function properly, as they provide the necessary conditions that support life and allow living organisms to thrive. A living factor in the environment, like plants or animals. Biotic factor. In simple terms, a biotic factor is any living part of an ecosystem that can affect other organisms. Imagine you're trying to set up a successful dinner party, but you're struggling to decide who to invite for the best atmosphere. Just like the right mix of guests can make or break the party mood, biotic factors like plants and animals play a crucial role in shaping an environment. In this analogy, the guests represent the biotic factors, where each person or living factor contributes to the dynamics and success of the environment, just as plants and animals do in an ecosystem. All the living and non living things interacting in an area. Ecosystem. An ecosystem is like a community where plants, animals, and non living things like water and rocks all work together. Imagine trying to organize a chaotic family gathering where each member has different needs and preferences. This is similar to how an ecosystem functions, with various living organisms and non living elements interacting in a specific area. Just as you might balance Aunt Mary's preference for quiet with the kids' need for play space, an ecosystem balances the needs of plants, animals, water, and sunlight to maintain harmony. An organism that uses energy from the sun to produce its own food, like plants. Autotroph. An autotroph is a living thing that makes its own food using sunlight or chemical energy. Imagine trying to make a home cooked meal without having any ingredients in your pantry. This is similar to how plants, as autotrophs, create their own food using sunlight, water, and carbon dioxide, without needing to shop for ingredients. Just as you might gather fresh vegetables from a garden to prepare a meal, plants harness sunlight through photosynthesis, turning raw materials available in their environment into energy rich food, demonstrating self sufficiency in both scenarios. Organic matter or animal waste that can be burned for energy. Biomass. Biomass is material from plants and animals that can be used as a renewable energy source. Imagine trying to figure out how much food is in your fridge without opening it. Just as you estimate the total amount of groceries by considering the weight and volume of each food item you've put in there over time, biomass measures the total mass of all living matter in a specific area. In this analogy, each food item represents an individual organism, and your fridge is the given area. Together, they combine to give you an overall sense of fullness or total mass, just like biomass does in an ecosystem. An organism that breaks down dead organisms and waste, like fungi or bacteria. Decomposers are organisms that recycle nutrients by breaking down dead material. Imagine you're cleaning out your refrigerator and you find leftovers that have gone bad. Just like you break down and dispose of these spoiled foods to make space for fresh groceries, decomposers like fungi and bacteria break down dead organisms and waste in nature. In both scenarios, the process of breaking down and clearing out the old to make room for the new is essential. You are the decomposer of your fridge, while fungi and bacteria do the same for the ecosystem, ensuring it remains clean and balanced. The food energy transfer between organisms in an ecosystem. Food chain. A food chain is a sequence that shows how each living thing gets its energy by eating another organism in an ecosystem. Have you ever played the game of passing a message down a line of people, only to find that the message changes slightly with each person? This is similar to how energy is transferred through a food chain in an ecosystem, where energy starts with the sun and is passed from one organism to another, changing form along the way. Just as the original message gets altered as it moves from person to person, the energy from the sun gets transformed from sunlight to plant matter to herbivore muscle and so on, illustrating how energy changes form as it moves through the food chain. A model of overlapping food chains in an ecosystem. Food web. A food web is a network of interconnected food chains showing how different organisms feed on each other in an ecosystem. Imagine trying to manage a group chat where everyone is talking to each other at once, sharing information and making plans. This chaotic yet interconnected conversation is similar to a food web in an ecosystem, where various plants and animals interact in a complex network of feeding relationships. Just as each person in the group chat contributes to the overall flow of conversation, each species in a food web plays a role in the ecosystem, with their interactions overlapping and influencing one another, much like messages bouncing between group members to create a dynamic and interconnected dialogue. An animal that eats only plants. Herbivore. Herbivores are animals that get their energy and nutrients by consuming plants. Imagine trying to pick a meal at a restaurant where you only eat vegetarian dishes. This is similar to the dietary choices of a herbivore, an animal that eats only plants. Just as you navigate the menu to find plant-based options that fit your diet, a herbivore navigates its environment to find suitable plant foods. Both are selective processes focused on plant-based nourishment. An organism that cannot make its own food, including all animals, is called a heterotroph. A heterotroph is an organism that eats other organisms to get energy. Imagine you have a car that needs gasoline to run, but can't produce gasoline on its own. This is similar to heterotrophs, which are organisms that must consume other organisms for energy because they can't create their own food. Just like the car depends on an external source, the gas station, to fill up its tank and keep moving, heterotrophs rely on consuming other living things to get the energy they need to survive. A step in the food chain or food web. Trophic level. A trophic level is the position an organism occupies in a food chain, like primary producers or top predators. Imagine you're in a multi-story shopping mall and you need to figure out which floor to go to for different types of stores. Just like each floor of the mall has specific types of shops and services, each trophic level in a food chain or food web has specific types of organisms, like producers or consumers. The connection here is that just as each floor in a mall supports a different shopping need, each trophic level supports a different role in the ecosystem, with energy being transferred from one level to the next, much like how money and products move through the mall. Large areas with similar climates, plants, and animals, like a tundra, taiga, or desert. Biome. A biome is a region on Earth with distinct climate, plants, and animals. Imagine trying to dress appropriately for the weather every day, whether it's a sunny beach day or a snowy winter morning. Just like your wardrobe changes based on the weather, a biome is a large area where the climate dictates the types of plants and animals that live there, such as in a tundra, taiga, or desert. Just as you wouldn't wear a swimsuit in a blizzard, plants and animals in a biome have adaptations that suit the specific climate and conditions, ensuring they thrive, much like your choice of clothes helps you stay comfortable. An animal that only eats other animals. Carnivore. A carnivore is an animal that predominantly consumes the flesh of other animals for its diet. Imagine you're at a party and all the delicious party snacks are only desserts, but you really crave savory food. This situation is similar to a carnivore's diet because just as you are seeking something specific that isn't present, a carnivore specifically hunts for other animals to eat, ignoring plant-based options. In this analogy, your craving for savory food represents the carnivore's need for meat, and the absence of savory snacks at the party mirrors how carnivores bypass plants in favor of animal prey to fulfill their dietary needs. An organism that feeds on dead organic matter. Detritivore. Detritivores are animals that eat dead plants and animals, helping to recycle nutrients in ecosystems. Imagine cleaning out your fridge and finding leftover food that's past its expiration date. Just like you need to get rid of those expired items to make space for fresh food, detritivores consume dead organic matter to clear away the old and make room for new life. In this analogy, your fridge is like an ecosystem. The expired food represents dead organic material, and the detritivore acts as the cleaner, ensuring the ecosystem stays healthy and balanced by recycling nutrients. Can eat both plants and animals. Omnivore. An omnivore is an animal that consumes both plants and animal matter as part of its diet. Imagine you're deciding what to have for dinner, and you're torn between ordering a vegetable stir fry or a juicy steak. This dilemma is similar to how an omnivore operates, as it has the flexibility to choose between eating plants or animals, much like your choice between vegetarian or meat options. Just as you can enjoy both a salad and a steak in a single meal, an omnivore's diet includes both plant-based and animal-based foods, allowing it to thrive in a variety of environments and situations. The movement of a chemical through the living and non-living parts of an ecosystem biogeochemical cycle. A biogeochemical cycle is the continuous recycling of nutrients and elements through the environment, organisms, and the Earth's systems. Imagine trying to keep track of a single dollar bill as it moves through various transactions in a busy city. Just like that dollar bill, a chemical in a biogeochemical cycle moves through different parts of an ecosystem, both living and non-living. In this analogy, the dollar bill represents the chemical. The people and shops it passes through are like the plants, animals, and soil in the ecosystem. And the city itself is the entire ecosystem where these exchanges take place. when a bacteria converts nitrates into nitrogen gas. Denitrification. Denitrification is the process by which bacteria change nitrates in the soil into nitrogen gas, releasing it back into the atmosphere. Imagine you're cleaning out your refrigerator and finding ways to turn leftovers into a simple, delicious meal. Just like how you creatively transform those leftovers into a meal, bacteria in the soil transform nitrates into nitrogen gas. In this analogy, the leftovers are akin to nitrates, which might be abundant but not in the most useful form, and the meal you create is like the nitrogen gas, a more streamlined and essential component for the ecosystem. This process, known as denitrification, is nature's way of recycling nutrients, much like how we find new uses for the bits of food in our fridge. The process in which soil bacteria convert nitrogen gas into ammonia is called nitrogen fixation. In simple terms, nitrogen fixation is how certain bacteria change nitrogen from the air into a form plants can use for growth. Imagine trying to turn a large, unmanageable amount of raw ingredients in your pantry into a delicious meal that's ready to eat. Just like how you need to convert those ingredients into something usable for dinner, soil bacteria convert nitrogen gas, which plants can't use directly, into ammonia, a form they can absorb and utilize. In this analogy, the raw ingredients are like nitrogen gas, the bacteria are the cooks transforming it, and the resulting meal is the ammonia plants need to grow. A substance that an organism needs to live, like water or minerals. Nutrient. Nutrients are essential materials that help living things grow and stay healthy. Imagine trying to complete a puzzle, but missing a few crucial pieces. Just like those pieces are essential to complete the image, nutrients are essential substances that organisms need to function properly. In this analogy, the puzzle represents the body, and the missing pieces are like nutrients such as water or minerals. Without them, the body cannot maintain its full health and operational picture. Organism that can make its own food, like all plants. Producer. A producer is a living thing that makes its own food through processes like photosynthesis. Imagine you're running late for work and realize you forgot your lunch at home. This situation is similar to how producers in nature, like plants, never have to worry about such a problem because they make their own food. Just as you might wish you could whip up a meal from thin air to avoid being hungry, plants use sunlight to produce their own sustenance through photosynthesis, ensuring they're always fed no matter where they are. A process by which some organisms, like bacteria, use chemical energy to produce carbohydrates. Chemosynthesis. Chemosynthesis is how certain organisms make food using energy from chemical reactions instead of sunlight. Imagine you're in a remote cabin without electricity and you need to cook dinner. Just like you might use a gas stove to transform fuel into heat to cook your meal, certain bacteria use chemical reactions to transform inorganic substances into energy-rich carbohydrates. In this analogy, the gas stove represents the bacteria's ability to use chemical energy, and the cooked meal is akin to the carbohydrates they produce through chemosynthesis. Unlike a plant, cannot make its own food. Instead, it eats other living things. Consumer. In science, a consumer is an organism that obtains energy by eating other organisms. Imagine you're trying to fix a broken appliance at home, but you lack the necessary tools. This situation is similar to the way some consumers in nature, such as animals, cannot produce their own food and must rely on eating other living organisms to obtain energy. Just as you need to borrow or buy tools to complete the repair, these consumers must borrow or acquire energy by consuming other plants or animals. In both scenarios, there is a dependency on external resources to fulfill a need. You need tools to fix your appliance, and consumers need other living things to obtain their energy. Microscopic, photosynthetic organisms that float near the water's surface, like algae. Phytoplankton are tiny water organisms that make their own food using sunlight, just like plants. Imagine you've ever been stuck in traffic, trying to get to work on a busy morning. Just like cars need to navigate the roads to reach their destinations, phytoplankton must stay near the water's surface to access sunlight for photosynthesis. In this analogy, the water's surface acts like the road, sunlight is the fuel, and phytoplankton are like cars, all trying to move efficiently and effectively to power life in the ocean. Floating animal plankton, zooplankton. Zooplankton is tiny aquatic animals that drift in water and are an important food source for larger marine organisms. Imagine you're at a crowded party, trying to navigate through a sea of people to get to the snack table. Just like you maneuver between groups of partygoers, zooplankton drift and float through vast ocean currents among other marine organisms. The connection here is that, much like you moving with the flow of the crowd to reach your destination, zooplankton ride the ocean currents, traveling and feeding as they go, with their direction largely determined by the surrounding water movement. Tiny microscopic organisms that float or drift in water. Plankton. Plankton are small creatures in water that form the base of the aquatic food chain, providing food for many marine animals. Imagine trying to navigate through a crowd at a busy concert where everyone is moving in different directions. Just like you might find yourself being pushed or pulled along by the flow of the crowd, plankton are tiny organisms that drift along with the currents in water. The common problem of getting swept up in a crowd mirrors how plankton are carried by water currents, as both you and plankton have limited control over your direction and are influenced by the larger forces surrounding you. The diagram of energy loss through a food chain. Energy pyramid. An energy pyramid is a graphical representation that shows how energy decreases as it flows through different levels of a food chain. Imagine you're trying to keep a series of candles lit in a windy room. Each candle represents a step in the process of energy transfer, where the wind is like the inefficiency in energy transfer within a food chain. Just as you lose some flame to the wind with each candle you try to light, energy is lost at each trophic level in the energy pyramid, from producers to consumers. The wind symbolizes the natural inefficiencies where only a portion of the energy is passed on at each level, much like how only a fraction of the flame reaches each subsequent candle, highlighting the diminishing energy available as you move up the food chain.